students, welcome to Home School. In this session, we are going to discuss a sample question paper. Okay, let's see what is the first. Yes, there are some general instructions. Before that, you have to know the total score of this exam is 70 and it takes 3 hours. Okay, let's read the general instructions. There are 33 questions in this question paper and all questions are compulsory. Session A, question number 1 to 2 are case-based questions having 4 MCQs or reason assertion type based or given passage each carrying 1 mark. And section A, question 3 to 16 are MCQs and reason assertion type questions carrying 1 mark each. And section B, question number 70 to 25 are short answer question which carry 2 marks each. And section C, question number 26 to 30 are short answer questions that carry 3 marks each. And finally, section D, question number 31 to 33 are long answer questions which carrying 5 marks. There is no overall choice. However, internal choice have been provided. Use the calculator and log tables are not permitted. Okay, just go through this general instructions and let's answer the question papers. We can start the question paper. Okay, here, session A. Session A is consists of objective type. Okay, we have a passage here. Have to read that passage and based on this passage, have 4 MCQs are given. Okay, so let's answer the first. Read the passage given below and answer the following questions. Okay, alcohols are versatile compounds which behave both as nucleophiles and as well as electrophiles. They behave as nucleophiles in the reactions in which the bond between OH is broken. On the other hand, the bond between CO is broken when alcohol act as electrophiles. These reactions are carried out in the presence of acid to form protonated alcohols which react as electrophiles. Therefore, alcohols undergo reactions involving cleavage of OH bond and CO bond. When they react with the metals such as sodium, potassium, magnesium, etc., they form metal alkoxide and liberates hydrogen gas. And these reactions show the cleavage of OH bond and alcohols are acidic in nature. The reaction of alcohols with hydrogen halides that proceeds through the formation of carbocation, showing the cleavage of CO bond. The reaction is SN1 reaction and quite often gives rearranged products which are different from the expected products. These are due to 1,2-hydride or 1,2-methyl shift forming stable carbocations. Okay, so the whole passage is about how this alcohol reacts as electrophiles and as well as nucleophiles. Okay, some of the reactions are also mentioned here. Okay, so we have to answer 4 questions based on this passage. Let's see. Yes, first question. The following questions are multiple choice questions. Choose the most appropriate answer. Okay, the first question is, arrange the following alkoxides in the descending order of basic strength. Okay, we have 3 alkoxides here. Okay, so based on the basic nature, we have to arrange these 3. Okay, so what is basic nature? Basic nature is electron-rich nature, right? Okay, it should have electron pair. It should be electron-rich. So, considering these 3 alkoxide, we know that the alkyl group, R group, which is electron donating group or electron-rich group. Here we can see, here it is a primary alkoxide and it is secondary and the last one which is a tertiary alkoxide. Here we can see that the alkyl group is electron donating group that increases the negative charge on this oxygen atom. Thereby, this alkyl groups that makes the alkoxide more electron rich. So, considering this fact, which is more basic in nature, yes, it should be the tertiary one. Then, what happens? Secondary and finally, primary. So, what is the correct option? Yes. The first one is the correct option. R3CO, which is greater than R2CHO and RCH2O. Okay. Now, moving on to the next question. The reactivity of alcohols towards HI is in the order. So, here we have to find the order of reactivity of different alcohols towards HI. Okay. We know that there is a carbocation is formed by this reaction. Which carbocation is more stable? Primary, secondary or tertiary? We know that tertiary carbocation is more stable because of the electron releasing R group. Okay. So, the tertiary carbocation will be more stable. That means there is a possibility of the increased reaction with the HI. Okay. So, tertiary carbocation forming, that means tertiary alcohol which is more reactive towards the HI, and then secondary, finally primary. So, the correct option is B, that is tertiary greater than secondary primary. Okay. Now, moving towards the next question. Which of the following statement is not true? Okay, we have 4 statements here. We have to check which of the following statement is not true. Let's see. First statement. Ethanol reacts with the sodium metal to liberate hydrogen gas. Yes, that is correct. Ethanol reacts with the sodium metal, results in the formation of what? Sodium ethoxide plus hydrogen gas. So, it is a true statement. Then, the next one. Water is better proton donor than ethanol. Yes, that is also a correct statement. Water is a better proton donor in comparison with the ethanol. In ethanol, there is a presence of R group. Okay, that decreases the proton donation of ethanol in comparison with the water. Then, third one. During esterification of carboxylic acid and alcohol, the cleavage of OH bond of carboxylic acid occurs. Is that true? Is that correct? No. Okay, we already studied the esterification reaction. They specify here, that is, the esterification reaction that is based on the cleavage of CO bond. So, this is not true. Then the last statement, HI is more reactive than HCl towards ethanol. Yes, that is also correct statement. So, which is the correct answer? Yes, that is C. It is the correct answer. Now, moving on to the next. Yes, fourth one. The product of the reaction is, here have reaction, you have to predict the product of this corresponding reaction. Yes, here we have CH3CH2CH2OH plus HI in the presence of red phosphorus and 420 Kelvin temperature condition. Okay, so what is the reagent here? We have, yes, we have propanol here. Propanol react with the HI in presence of a strong reducing agent red phosphorus. What happens? Alcohols converted into alkanes in presence of strong reducing agents like red phosphorus. So, the corresponding alkane will be, yes, CH3, CH2, CH3. So, the correct option is C. Okay. Yes. Propane is formed. Moving on to the next question. Yes. We are moving on to the second passage type question. Let's read this passage first. The French chemist Francois Raoult gave a quantitative relationship between partial pressures and the mole fraction of two components of a solution of two miscible liquids. According to Raoult's law, at a given temperature, for a solution of volatile liquids, the partial pressure of each component in the solution equal to the vapor pressure of pure component times its mole fraction. The solutions which obey Raoult's law exactly over the entire range of concentration are called ideal solution. Physically, such solutions are possible only if the molecules of the two components are of the same size and have exactly the same size and exactly the same interactions as between molecules of each pure components. However, many liquid solutions show deviations from ideality which indicate certain solute-solvent interactions. The non-ideal solutions can be of two types. One showing positive deviation from Raoult's law and the other showing negative deviations from Raoult's law. The ideal solutions can be separated from each other by fractional distillations. But non-ideal solutions cannot be completely separated from each other by distillation process. Rather, they form constant boiling mixtures corresponding to definite composition. Such mixtures are known as or called as eardrops. Okay, so we read the passage. In this passage, they are discussing about the different kinds of solutions. Okay, here we talked about the azeotropic mixture, ideal solution, non-ideal solution. Okay, so based on these topics, we have to answer some questions. Let's see what is the first question based on this passage. Okay, students, first one. The following questions are multiple choice questions. Choose the most appropriate answer. Okay, the first one is here. Which of the following is not true about ideal solution? Okay, we have 4 options here. Which is not true about an ideal solution? The first one, delta G mixing is equal to 0. And B, delta V mixing is equal to 0. C, delta H mixing is equal to 0. And D, it obeys Raoult's law. Okay, we already discussed that. An ideal solution that will obey Raoult's law in its entire range of concentration or composition. So, D is correct. And for ideal solution, delta H mixing and delta V mixing will be 0. Yes, so these two statements are correct. So, which one is not true? Delta G mixing is 0. That is the wrong option. Hence, the correct answer of this question is A, delta G mixing is equal to 0. Okay, now moving on to the next question. Second one. Which of the following forms non-ideal solution with a positive deviation from Raoult's law? Okay, we have 4 options here. We have to find which forms of non-ideal solution which having positive deviation from Raoult's law. Okay, which show positive deviation from Raoult's law. So, in order to answer this question, we have to study some of the examples for solution showing positive deviation as well as negative deviation. Okay, so here we can see that option C is the correct option because acetone plus carbon disulfide. Acetone plus CS2. That solution show positive deviation from Raoult's law or ideal behavior. Okay. Next question. 1 mole of liquid A and 2 moles of liquid B that form a solution having a total vapor pressure of 46 torr. The vapor pressure of pure liquids A and B are 36 and 48 respectively. Then the solution will be, okay, we have to find the nature of the solution formed by the mixing of these two pure solutions A and B. Okay, so we have 4 options here. Before reading these options, we have to find that what is the total vapor pressure of that solution. We know that P total will be P0A plus P0A chi A plus P0B chi B. So, this will be the total pressure. Okay, so let's see. P0A, the vapor pressure of pure liquid A is found to be 36. 36 into, we have to find the mole fraction. Here, A is what? 1 mole of A. So, we can take it as 1/3 plus P0B. Vapor pressure of the pure liquid B is 48. 48 into what? 2/3. So this will give 42. So according to the law, the total vapor pressure or the P total of the solution must be 42 torr. But the resulting solution have total vapor pressure of 46 torr. That means it is higher than expected value, that is 42. What does that mean? Yes, it show positive deviation. Okay, it is more than expected value. So the correct option is that shows positive deviation from Raoult's law. Okay, now moving on to the next. Fourth question. A non-ideal solution forms maximum boiling azeotrope. Which of the following is not correct for the solution? Okay, so we have to find which of the following is not correct for a non-ideal solution. We're showing maximum boiling point azeotrope. Okay, let's see. Here, option A, delta V mixing is positive. B, delta H mixing is negative. And C, PA is less than P0A chi A and PB is less than P0B chi B. And D, heating decreases solubility. Which is the correct answer? We know that a solution forming maximum boiling azeotrope, which is a solution showing negative deviation. So, which is the incorrect option? Yes, delta V mixing is positive, which is not true for a solution showing negative deviation. That means a solution showing maximum boiling azeotrope. Okay, so option A is the correct answer. Now, moving on to the next question. Yes. So, it is the second part of the section A. Following questions number 3 to 11. They are the multiple choice questions which carrying 1 mark each. Let's read the first question. It is the third question in the session. Which of the following option will be the limiting molar conductivity of CH3COH if the limiting molar conductivity of CH3CONa, which is 91 Siemens centimeter square per mole. Limiting molar conductivity of individual ions are given in the following table. Okay, we have the limiting molar conductivity of CH3CONa and we have to find the limiting molar conductivity of CH3COH, which is a weak electrolyte, and limiting molar conductivity of individual ions are given here. Let's find CH3 limiting molar conductivity of CH3COH. How can we calculate? Yes, by using the given data. Limiting molar conductivity of CH3CONa minus limiting molar conductivity of Na plus limiting molar conductivity of H plus. Okay, from this equation, we can calculate limiting molar conductivity of CH3COH. Okay, so the corresponding values, we have to put the corresponding values of this in this equation and we will get the answer 390.5 Siemens centimeter square per mole. Okay, just by putting these values, value of H, Na plus, H plus and this 91 will get that value. Okay, so 390.5 Siemens centimeter square per mole is the correct answer. Okay, now moving on to the next. Yes, the fourth question. Curdling of milk, it is an example of. Okay, this is the question for biomolecules. We already studied about curdling of milk, which is the correct answer, which is the example of. Yes, that is the denaturation of protein. Yes, curdling of milk is an example of denaturation of protein. We already discussed about what is denaturation of protein, what is the structure of protein, and what happens. A protein is denatured. Its physical and biological properties changes, but its chemical composition remains the same. Okay. Now, moving on to the next question, fifth one. When 1 mole of benzene that is mixed with 1 mole of toluene, the vapor will contain. So, we have to find what the vapor will contain if we mix 1 mole of benzene with 1 mole of toluene. So, here, vapor pressure of benzene is given, yeah, that is 12.8 kPa, and vapor pressure of toluene is given, that is 3.85 kPa. Okay, so based on this information, we have to find what kind of what is the composition or what kind of vapor will be that. Okay, so we have 4 options here. Equal amount of benzene and toluene as it forms an ideal solution. Unequal amount of benzene and toluene as it forms in non-ideal solution. Higher percentage of benzene and higher percentage of toluene. So here we can see that the vapor pressure of benzene is more, right? That means benzene is more volatile in comparison with the toluene. So the vapor pressure of benzene will be more, means more amount of benzene. When we mix these two, benzene and toluene, what happens? More amount of benzene will be in its vapor state. That's why its vapor pressure is more. So from this information, we can find that more amount of benzene will be in the vapor state. That means the higher percentage of benzene. Okay, so option C is the correct answer. Okay, now moving on to the next. Yes. Sixth question. Which of the following is a reason for zinc not exhibiting variable oxidation state? We know that zinc is not exhibiting variable oxidation state. Why? A reason for a d block element to show or exhibit variable oxidation state. What is that? Yes, it is the unfilled or incompletely filled d orbitals. But in the case of zinc, let's write the valence electronic configuration of zinc. 4s2 3d10. Here we can see that the d orbital is completely filled. So that is why zinc does not exhibit variable oxidation state. So the correct option is B, that is completely filled 3d subshell. Now moving on to the next question. Yes. Propanamide on reaction with the bromine in aqueous NaOH gives. So we have to write the product of a reaction, that is propanamide on reaction with the bromine in aqueous NaOH. Okay, let's see the general equation, that is, this is a RCO NH2. This is an amide which is on reaction with the bromine in NaOH. What will be the product? Yes, RNH2 plus Na2CO3 plus H2. Okay, this is the product for the reaction. So, let's concentrate on this product, that is RNH2. Okay, an amide react with the bromine in NaOH. What happens? What will be the result? An amine which having one carbon atom less than the reactant. So, if we take propanamide, what will be the result? It will be an amine which is one carbon atom less than the reactant, that is propanamide. So the correct option is ethanamine. Okay, is that clear? Moving on to the next. Yes. Ampidentate ligands like NO2 and SCN are, whether it is unidentate, didentate, polydentate, or has variable density. Which is the correct option? We know that an ampidentate ligand is a ligand which can attach to the central metal atom through 2 ways, but only one at a same time. So here, NO2 and SCN, both of them are ampidentate ligands, but they can only attach through one atom at a time. So, From that, we can see that they are unidentate ligands. Okay, I think it is clear for you. Moving on to the next. Yes, ninth question. The formula of the coordination compound. Okay, we have a coordination compound here, that is tetraamine aquachlorido-cobalt-3 chloride ester. So we have to find the formula of the above coordination compound. Okay, let's try to write the formula. Okay, here it starts with the tetraamine. That means there is 4 what group? NH3 group present in that compound. Okay, so 4 NH3. NH3, 4. Okay, and then aquachlorido. Okay, there is a presence of H2O. The next ligand is H2O. And then chlorido. There is a presence of chlorine atom. Okay, here there is a chlorine atom inside the coordination entity. And the central metal ion is cobalt. Okay, now we have to find the number of what counter ions present outside the coordination entity, that is chloride. So, in order to satisfy that oxidation number, that is oxidation number of cobalt is 3. So, the compound will be Cl2. Okay, which is the correct option? Yes, this is the correct option. Okay, now moving on to the next question. Yes, identify A, B, C and D. Okay, here we can see C2H5Cl, which reacts with the different reagents, and we have to find the corresponding products. Let's see the first one. Here, C2H5Cl, which reacts with the aqueous KOH. What happens there? When C2H5Cl that reacts with the aqueous KOH, that results in the formation of corresponding alcohol. Okay, so A is C2H5OH. Okay, now moving on to the next. C2H5Cl that reacts with the alcoholic KOH. You know that when it is reacts with alcoholic KOH, there happens dehydrohalogenation that results in the formation of alkene. Here, in the case of C2H5Cl. Okay, so the B will be corresponding alkene, that is CH2 double bond CH2. Okay, so the next one, C. C2H5Cl, when it is reacts with AgCN. When it is reacts with AgCN, that results in the formation of what? Isocyanate, that is C2H5NC. Then, what happens when it is reacts with the KCN? Yes, option D will be C2H5Cl. Okay, so what is the correct option? Yes, the last is the correct option. A is C2H5OH, B is C2H4 and C is C2H5NZ and finally D is C2H5CN. Okay, now we are moving on to the next question. Yes, the oxidation state of nickel in NiCO4, nickel tetracarbonate or tetracarbonyl nickel. Okay, here we know that the charge of carbonyl group, it is 0. It is a neutral ligand, right? So, in effect, the charge or oxidation state of nickel, the oxidation state of nickel in NiCO4 is 0. Okay, so the correct option is option C, 0. Okay, is that clear for you? Now, talk about or deal with the assertion reason type question. Okay, let's read this. In the following questions, that is question number 12 to 16, a statement of assertion that is followed by a statement of reason is given. Choose the correct answer out of the following choices. Okay, we have 4 different choices here. The first thing that we have to do is just read the assertion and reason. And we have to find the reason is the assertion statement or the reason statement is correct or not. Or the reason is the correct explanation of the assertion. Okay, let's find out. Let's read the first question. Yes. Assertion. D plus glucose. It is dextrorotatory in nature. Okay. What is dextrorotatory nature? We know that when a plain polarized light, when it is passed through the glucose solution, what happens? Glucose rotate the plain polarized light into the right direction or clockwise direction. That is called the dextrorotatory nature. The plus sign here, that indicates the dextrorotatory nature. And let's read this reason. D represent dextrorotatory nature. Is that true? Is that correct? No. Here, this D represent the configuration of that molecule. D shows that whether the OH group in the asymmetric, lowest asymmetric carbon situated in the right side or left side. So, D simply represents the configuration of molecule. Okay. So, here the assertion is correct, the reason is false. So, what is the correct option? Yes. Assertion statement is correct, but the reason is wrong. C is the correct option. Now, moving on to the next. 30th question. Assertion. Nitric acid and water form maximum boiling point azeotrope. And the reason, azeotropes are binary mixtures having the same composition in liquid and vapor phase. Okay, let's read the first one. Assertion, that is nitric acid and water form maximum boiling point azeotrope. Is that a correct statement? Yes, of course, yes. We know that nitric acid and water, okay, that show negative deviation. That means if we consider a binary mixture which having components A and B. So, for a solution showing negative deviation, the AB interaction will be greater than AA and BB. So, in effect, they show negative deviation from Raoult's law and they form maximum boiling point azeotropes. Okay, so the first statement is correct. And the reason, azeotropes are binary mixtures which having same composition in liquid as well as in its vapor phase, which is also a correct statement. It is the definition of azeotropes. Okay, but we can see that both two statements are true, but reason is not the correct explanation for the assertion. So, what will be the correct option here? Yes, B. Assertion and reason both are correct statement, but reason is not correct explanation for assertion. Okay. Assertion. Carboxylic acids are more acidic than phenols. Is it a true statement? Yes. Carboxylic acids are more acidic than phenols. And the second statement, phenols are ortho-para-directing. Yes, that is also true. But the problem is, both of them are correct. But phenols are ortho-para-directing, that is the reason for the more acidity of carboxylic acid? No. We can see that this is the structure of a carboxylic acid and this is the structure of a phenol. Okay. Acidity means or acidic character means its tendency to donate the H plus ions. So here H plus is donated, that forms a carboxylate ion, and here if the H plus is donated, we'll get a phenoxide ion. Their stability explains the acidic strength. The remaining structures, that is carboxylate ion and the phenoxide ion, if they are stable, then it is a powerful acid. Here we can see in the case of a carboxylate ion, it is resonance stabilized with the two equivalent structures. Two similar structure. Here we can see two similar structure. That is why carboxylate ions are more stable in comparison with the phenoxide ion. Here also we can see that phenoxide ion is also resonance stabilized, we'll get so many resonance stabilized structures. So many resonance structures here. Okay, here we can draw different kinds of structures. And from these structures, we can see that the negative ion that is concentrated on ortho and para directions. These are the different resonance structures of, yes. Okay, these are the different resonance structures of phenoxide. Even though both of them shows different resonance stabilization structures, which is both of them are resonance stabilized, but here there is a peculiarity, that is they get two structures and they are equivalent. Okay, similar structures. That is why carboxylic ion is more stable. That is why carboxylic acids are more acidic than phenol. Okay, so from this we can understand that both of the statements are true, but the reason is not correct explanation of the assertion. Okay, so the correct option is B. Assertion and reason both are correct statement, but reason is not correct explanation of the assertion. Okay, now we are moving on to the next question, 15th question. Assertion. Methoxyethane that reacts with HI to give ethanol and iodomethane. Is that a correct statement? Yes. Let's write methoxyethane, CH3O, CH2, CH3 that reacts with HI. When it reacts with HI, that will give what? Yes, ethanol and CH3, CH2OH plus iodomethane, that is CH3I. Okay, so the assertion is the correct statement. And the second one, reason. Reaction of methoxyethane with HI follows SN2 mechanism. Is that correct? Yes. Reaction of methoxyethane with HI that follows SN2 mechanism. We know that methoxyethane, which is a primary ether. Okay. Because it is a primary ether, it reacts with HI through SN2 mechanism. Okay. But if it is a tertiary ether, what happens? Which pathway it will follow? It will follow SN1 mechanism. So, both assertion and reason are correct, and reason is the correct explanation of assertion. So, the correct option is A. Assertion and reason both are correct statement, and reason is correct explanation for assertion. Okay. Now, moving on to the next. Yes. Assertion. Fe3 plus is more stable than Fe2 plus. Okay. And Fe3 plus, the reason is Fe3 plus has 3D5 configuration while Fe2 plus has 3D6 configuration. Let's see. Consider, we know that the electronic configuration, the atomic number of Fe is 26. So, when we write electronic configuration, we'll get the valence shell electronic configuration is 4s2 3D6. In the case of Fe2 plus, it is 3D6. In the case of Fe3 plus, it is 3D5. Okay. We know that the maximum number of electrons that can be accommodated in a d orbital, it is 10. Okay. If the d orbital is completely filled, then that species will be stable. And also, we already studied in our 11th standard, if it is half filled, that means if it is contain 5 electrons, which is a half of 10, when it is half filled, it will also possess extra stability. So, here in the case of Fe3 plus, it possesses 3D5 configuration. That is why Fe3 plus is more stable than Fe2 plus. So, the reason for that is it has 3D5 configuration. Okay, so the assertion is the correct statement and also reason is the correct statement. Reason is the correct explanation of the assertion. So the correct option is option A. Assertion and reason both are correct statements and reason is correct explanation for assertion. Okay, now moving on to the 17th question. Okay, now we are moving on to the section B. Here, the following questions, question number 17 to 25, there are short answer type questions which carry 2 marks. Okay, from now on, each question carry 2 marks. Let's see. 17th question. Which alkyl halide from the following pair is chiral? And the second one undergoes SN1 reaction faster. Okay, so here we have to find which is chiral and which undergo SN1 reaction faster. So, in the case of chirality, the one thing that we should bear in your mind is, for a molecule to be chiral, it should possess asymmetric carbon. What is meant by asymmetric carbon? Its 4 valencies are attached to 4 different groups. So, here we can see that CH3, CH2, CHBr, CH3. The second option. Here we can see that in the case of here, this carbon. Let me write like this. This carbon, that is CH3, CH2 and one valence is H, one is Br, one is CH3. Okay, here we can see the presence of an asymmetric carbon. Okay, so the correct option is option B. Since it possesses a asymmetric center, it shows optical activities. It is chiral in nature. Okay, so chiral compound is B. Then the next one, which undergoes SN1 reaction faster. Okay, so in order to answer this question, we have to bear some things in our mind. Okay, primary compounds or primary things or primary compounds that follows what? SN2 mechanism. If it is a tertiary, it will follow SN1 mechanism. Here we can see that a tertiary halide. Okay, that is a tertiary halide. So that will follow SN1 reaction. A is the correct option for the second one. Okay, now moving on to the next question. Yes, 18th question. A glucose solution which boils at 101.04 degrees Celsius at 180. What will be relative lowering of vapor pressure of an aqueous solution of urea which is equimolar to given glucose solution? Okay, here there is a glucose solution that boils at 101.04 degrees Celsius. And we have to find the relative lowering of vapor pressure of an aqueous solution which is equimolar to the glucose solution. So, in order to find that relative lowering of vapor pressure, we have to find the molarity M of the glucose solution. Okay, here delta TB is given. Boiling point of glucose which is given, that is 101.04 degrees Celsius. And also we know that since it is a glucose solution, we know the boiling point of what? Water, right? It is 100 degrees Celsius. Okay, from this data, we can find delta TB. Okay, delta TB is equal to 101.04 minus 100 degree. We'll get 1.04 degrees Celsius as the delta TB value. Okay, and also Kb is given. We have delta TB and Kb values. From this, we can find what? molality of this glucose solution. Here, there is a relationship between delta Tb molality and Kb. I into Kb into M. Delta Tb is already found. 104 is equal to, we know that Van Hoff factor I for a glucose solution, it is 1. So, 1 into Kb is given 0.52 into M. Okay, from this data, M is equal to 1.04 divided by 0.52, which will be equal to 2. Okay, so molality of the glucose solution is 2, same in the case of urea, which is equimolar with the glucose solution. So, molality of urea solution, it is, which is also 2 molar. Okay, now we have to find the relative lowering of vapor pressure. Here, the relative lowering of vapor pressure of urea solution, which is connected to the mole fraction of that urea present in that solution, which is directly connected to the mole fraction of urea present in that solution. So, if we find Chi2 or chi-urea, we can calculate the relative lowering of vapor pressure. That is the mole fraction of urea is the relative lowering of vapor pressure. So, how we can calculate? Divided by plus in solution in water. Okay, here we know that since it is a 2 molar solution, what is meant by 2 molar? 2 moles in 1000 gram of water. 2 moles in 1000 gram of water. So, number of moles of urea will be 2. And we have to find number of moles of water. We can calculate from this data here, that is 1000 by number of moles of water can be calculated, and water is equal to molecular mass of water, that is 18, we'll get 55.55. Okay, just substitute this value here, 55.55, that is 2 divided by 57.55, we finally get the value 0.034 atm. This is the relative lowering of vapor pressure in the case of this one. I hope that is clear for you. Now, moving on to the next question. Yes, 19th question. Write the electronic configuration of ion in the following complex ion and predict the magnetic behavior. Okay, here we have a coordination compound FeH2O6 times 2 plus. And we have to find what? Yes, the electronic configuration of the ion, okay, or the central metal ion. And we have to find the magnetic behavior of that complex. Okay, let's see. Let's write the coordination compound here, FeH2O6 times 2 plus. Okay, so in order to write the electronic configuration, we have to find the oxidation state of the central metal ion, that is X plus H2 is a neutral ligand plus 2, which is equal to 0. X is equal to plus 2. Okay, so the oxidation state of Fe is plus 2. So, we have to write the electronic configuration of Fe2 plus ion, that is 3d6. It is a 3d6 compound. And we have to find its magnetic behavior. Let's see. Let's draw the d orbital for them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, here we can see that the presence of 4 unpaired electrons. Okay, if there is unpaired electrons present in that compound, it is paramagnetic in nature. presence of unpaired electrons means it is a paramagnetic compound. Then we have to find its paramagnetic behavior or magnetism. Okay, there is a formula for that. Mu is equal to root of n into n plus 2. There is a formula for that. Here n is the number of unpaired electrons. We can write it as number of unpaired electrons is 4. 4 into 4 plus 2, that is root 24, will get 4.89 Bohr magneto. Which is paramagnetic in nature. This is the magnetic moment of this compound. Okay. Now, the second question, write the IUPAC name of the coordination complex. Here, we have a coordination complex. We have to find the IUPAC name. Okay. Before moving on to the IUPAC name, we have to find what? Yes, the oxidation state of the central metal ion. Here, we use the same X plus. We know that the charge of Cl2 is -1 into 2, since there is 2 Cl atoms. En is 0. It is a neutral ligand. For NO3, it is -1, which is equal to 0. So, X minus 3 is equal to 0. So, X is plus 3. Okay. So, cobaltin plus 3 oxidation state. Okay. Here, we have to find the names. The first one, we have to name the ligands. Here, this chlorine and ethylene diamine. So, based on the what alphabetic order, we have to name the chlorine first. So, let's write the name. Dichloro, and then we have 2 ethylene diamine here. 2 chloro, bis ethylene diamine, now we have to specify the central metal ion, cobalt with its oxidation state in Roman letters, cobalt 3 nitrate, just the counter ion. This is the IUPAC name of the compound. Okay. Now, moving on to the next. Let's read the 20th question. For a reaction, the rate-law expression is represented as rate is equal to K into concentration of A into concentration of B raised to half. Okay, this is the rate-law expression for a particular reaction. Now, we read the first question. Interpret whether the reaction is elementary or complex. Give reason to support your answer. Okay, students, we know that for an elementary reaction, its order will be equal to its molecularity. Okay, so order can be calculated from this expression. We know that how we calculate order. Yes, it is a sum of the powers of concentration terms. Here, 1 plus half, which is equal to, yes, 3 by 2, that is 1.5. Okay, we got the order of this reaction, that is 1.5. Now we have to check the molecularity. Is 1.5 is the molecularity of that particular reaction? Is it correct? No, because molecularity cannot be fraction. That means a molecularity of a reaction is the number of reacting species which is take part in a particular reaction. It is the number of reacting species. It cannot be 1.5. So from this, we can conclude that this reaction is not elementary. It is a, yes, complex reaction. Okay. Now, moving on to the next. Write the units of rate constant for this reaction if concentration of E and B is expressed in moles per liter. Okay. We have to write the unit of rate constant, that is the unit of K. Okay. From this rate expression, and it is given that is the concentration is represented in the unit of concentration, that is moles per liter. Okay, let's do that. We know that rate is equal to K into concentration of A raised to 1 into concentration of B raised to half. Okay, this is the rate law expression. From this expression, we can write K is equal to Yes, K is equal to rate divided by, yes, concentration of A raised to 1 into concentration of B raised to half. Okay, we can rearrange the equation in this manner. And also we know that rate is the, yes, concentration by time. Okay, so concentration is represented in moles per liter. So we can write it as moles per liter by second. Time is represented in seconds. Okay, so rate is equal to moles per liter by second. So we can substitute this in here in order to find the unit of K. That is moles per liter by S. We know the units of concentration terms here. That is moles per liter. Moles per liter raised to 1 into, in the case of B, moles per liter raised to half. Okay, so from this equation, we'll get the unit K is equal to mole raised to minus half, liter raised to half, and second inverse. Yes. Okay, from this equation, we will get the final answer. That is, the unit of K is equal to moles raised to minus half, L raised to half, and second inverse. Okay, so I hope this question is clear for you. Yes, carry out the following conversions in not more than 2 steps. Okay, we have 2 conversions which needs not exceed 2 steps. Let's see the first one. Aniline to chlorobenzene. Let's see. First, aniline is here. Okay. We do diazotization here. Na2 by HCl. We are going to convert it into a diazonium salt. N2 plus Cl minus. When it is treated with the Cu2Cl2, we will get, yes, we get chlorobenzene. This is the path for conversion of aniline to chlorobenzene. Then let's see the second one. 2 bromopropane to 1 bromopropane. Let's see. CH3 CH Br CH3. It is bromopropane. Okay. Then when it is treated with the alcoholic KOH, what happens? Dehydrohalogenation occurs. Dehydrohalogenation. Okay, here we can see that a Br and a hydrogen just eliminated minus HBr. Then we'll get CH3 CH double bond CH2. Okay, alkane is formed. Then it is treated with the HBr in presence of H2O2. Okay, we are familiar with this. Okay, anti-Markovnikov's rule. Here, addition of HBr in presence of a peroxide, that will result in the formation of CH3 CH2 CH2Br. The negative part of the addendum goes to the carbon having greater number of hydrogen. That is anti-Markovnikov's rule. Okay, here the Br, the negative part goes to the carbon having greater number of hydrogen. That is here. So, there forms 1 bromopropane. Okay, this is the best method for the conversion of 2 bromopropane to 1 bromopropane. Okay, now moving on to the next question. 22nd question. When 3-methyl butan 2-ol is treated with HBr, the following reaction take place. Okay, here we can see 3-methyl butan 2-ol. When it is reacts with HBr, we get the product. Okay, so the question is, give a mechanism for this reaction. So we have to write the mechanism for the following reaction. Okay, let's start. This is the starting material. CH, CH3, CHOH, CH3. Okay, we have 2-methyl butane 2-ol. Okay, first step is when it is reacts with the HBr, that is H plus protonation. Here we can see that there is lone pair of electrons in oxygen. It will abstract this H plus proton and here forms, yes, CH3, CH, CH3, CH, OH2 plus CH3. Okay, the next step is elimination of H2 molecule. Okay, H2 molecule is eliminated from here and that will result in a formation of a carbocation. Let's see. CH3, CH, CH3, CH plus CH3. Okay. So, in the next step, there occurs a hydride transfer. Here we can see in this carbon there is a hydrogen atom. Okay, this hydrogen is transferred into this adjacent carbon which having a positive charge. And this reaction is known as 1,2 hydride transfer. This step is known as 1,2 hydride transfer. 1,2 hydride transfer. Okay, here we can see hydrogen is transferred into this. Okay, so the product will be another carbocation, CH3, CH3, positive charge, yes, CH2, CH3. Okay, so the next step is nucleophilic addition of what? Yes, Br minus. Nucleophile Br minus is attached to it. So, the product becomes, we'll get the product like CH3, CH, Br, CH3, CH2, CH3. Yes. This is the mechanism for the following reaction. Yes, we got the final product here. Okay, I hope you understand this mechanism. Next question. Okay, 23rd question. Predict the geometry of NiCN4 2-. Okay, let's see. We have to find or to predict the geometry of this coordination compound. Okay, before moving on to the prediction of the geometry, we have to find the oxidation number of central metal I. Okay, let's see. X plus the charge of the ligand Cn is minus 1. Minus 1 into 4 equal to minus 2. X minus 4 is equal to minus 2. X is equal to plus 2. Okay, so nickel in plus 2 oxidation state. Okay, let's write the electronic, valence shell electronic configuration of this Ni2 plus ion. Ni2 plus. Okay, we get 3D8 configuration. Okay, 3D8 species. So let's draw that. (3D) 4s 4p. Okay, this is the valence shell of nickel. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the ground state of this Ni2 plus ion. Okay, so let's find the geometry. In order to find geometry, we have to know what? Hybridization. Okay, here when it is in excited state, what happens? This plus 1 electron get paired. Okay, so we have 4 ligands here. The 4 ligands will attach to the 1, 2, 3 and 4. Okay, that means 1D, 1S and 2P. So the corresponding hybridization will be DSP2. DSP2 hybridization. And what will be the geometry? It is a square planar species. Square planar species. Okay. Now, moving on to the next question. Calculate the spin-only magnetic moment of CuNH34 times 2 plus. Okay, we have to find the spin-only magnetic moment of this coordination compound. Okay, same as the before. We have to find the oxidation state first. X plus NH3 is a neutral ligand. 0, which is equal to plus 2. That is X is equal to plus 2X is in plus 2 oxidation state. Okay, so the electronic configuration of Cu2 plus will be what? 3D9. Okay, this is the electronic configuration of Cu2 plus ion. Okay, so let's draw the electronic configuration here. 1, 2, 3, 4, 5. Okay, so this is the 3D9 configuration. Here we can see only one unpaired electron. Okay, here the N is equal to 1. We know the spin-only formula, that is mu is equal to root of N into N plus 2. Okay, here N is equal to 1, that is 1 into 1 plus 2. Okay, that is root 3, which is equal to 1.73 Bohr magneton. This is the answer. Okay, students, we are moving on to the next question. Yes, 24th question. The following haloalkenes that are hydrolyzed in presence of aqueous KOH. First one, 1-chlorobutane, and the second one, 2-chloro-2-methyl propane. And which of the above is most likely to give an inverted product? A racemic mixture. Justify your answer. Okay, this is the question. We have two haloalkenes here. We have to find which one gives an inverted product and which one gives a racemic mixture when it is treated with a aqueous KOH. Okay, here we have aqueous KOH, a nucleophilic reaction will occur, K plus plus OH minus. Here the nucleophile is OH minus, that is going to attack the species. Okay, since it is a nucleophilic reaction, it can undergo through two mechanisms. One is SN1 and the second one is SN2 mechanism. Okay, so based on the mechanism, we'll get different products. So, in order to understand which mechanism it will take, we have to understand whether it is primary or tertiary. Okay, we are talking about the two extreme cases, whether it is primary or tertiary. Let's write the molecular structure. 1-chlorobutane, CH3, CH2, 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 Cl. This is 1-chlorobutane. Okay, from that formula we can understand it is a primary haloalkane. Okay, and the second one, 2-chloro-2-methyl propane. Let's try the formula. C, Cl, CH3, CH3, CH3. It is a tertiary. Okay, so just bear this thing in your mind. SN1 and SN2 mechanism. In the case of SN1 and SN2 mechanism, if it is a primary, it will undergo SN2 mechanism. Okay, if it is primary, it will undergo SN2 mechanism. If it is tertiary, it will undergo SN1 mechanism. Okay, this is the thing that you have to bear in your mind. Okay, you have to understand this thing. And based on this, we will get two different products. Okay, here, the first one is a primary species. So, it will undergo what? SN2 mechanism. In the case of SN2 mechanism, what happens? The nucleophile will attack from the behind. Okay, so in effect, the resulting product will be inverted in its configuration. So, 1-chlorobutane, that will result in an inverted product. And the second one, 2-chloro-2-methylpropane. It will undergo SN1 mechanism. Okay, in the case of SN1 mechanism, here we can see that the nucleophile cannot attack from behind because of the bulky groups. There are bulky groups in either side. So, it cannot be attacked from the back side. So, in effect, the resulting mixture will be a racemic mixture. The resulting product will be a racemic mixture. So, 2 is the answer for the second one. Okay. Moving on to the next, 25th question. The following results have been obtained during the kinetic studies of the reaction. Here we have reaction P plus 2Q gives R plus 2X. Okay, so these are the different experiments and we will get the initial concentration of P and initial concentration of Q and initial rate of formations are given here. Here we have to determine the rate law expression for this reaction. Okay, so the question is, have to find the rate law expression. Okay, we know that rate is equal to K into concentration of P raised to X and concentration of Q raised to Y, some other number. Okay, here we have to find these powers X and Y. Okay, so using the information given in the table, we have to find the X and Y values here. Okay, let's see. Let's take rate of the first reaction here. Rate of the first reaction. Okay, here in the case of first reaction, initial rate formation, that is 3 into 10 raised to minus 4, which is equal to K into concentration of Q is found to be what? Yes, 0.10 raised to X into 0.10 raised to Y, which is the concentration of Q there. Then consider the second one, rate of the second reaction. Here we have rate of the initial rate of second reaction, that is 9.0 into 10 raised to minus 4. 9.0 into 10 raised to minus 4, which is equal to what? Yes, initial concentration of P is 0.30 and 0.30 of that of Q. K into 0.30 raised to X into that of Q is 0.30 raised to Y. Okay, then consider the third one, rate of the third. Okay, here initial of P is 0.10 and that of Q 0.30 and initial rate of formation is 3.0 into 10 raised to minus 4. Okay, let's write this information, 3.0 into minus 4, which is equal to K into 0.10 raised to X into 0.30 raised to Y. Okay, so we took 3 different experiments and the rate expressions. Okay, so based on this, we have to calculate what the values of X and Y. For that, first we can take 1 and 3. Okay, let's take 1 and 3 and divide equation 1 by 3. Let's see what happens there. This equation. Okay. Here we can see 3.03 into 10 raised to minus 4 equal to k into 0.10 x into 0.10y divided by this one 3.0 into 10 raised to minus 4 equal to k into 0.10 raised to x into 0.30 raised to y. Okay. This can be cancelled and this term can be cancelled. So, finally, we will get 1 is equal to 1 by 3 raised to y. Okay. So, from this expression, we can calculate the value of y as y is equal to 0. Okay. So, we got the value of y here. Okay. Now, we are going to calculate what the value of x. We know the expression, that is right to. Okay, we know that 9.0 into 10 raised to minus 4 is equal to what? K into 0.30 raised to x into 0.30 raised to y. So, let's do 2 by 3 here. Divide equation 2 with equation 3. Okay, let's see what happens here. Equation 2 divided by 3.0 into 10 raised to minus 4 equal to k into 0.10 raised to x into 0.30 raised to y. Okay, we'll get 3 is equal to, just cancel the similar terms, k into, k is also cancelled. Okay, we'll get 3 raised to x. 3 is equal to 3 raised to x. So, from this, the value of x is equal to 1. So, here we got the both values x and y. So, the rate equation, rate is equal to k into concentration of P raised to just x, that is 1, and that of Q just 0, right? So, the equation can be written as rate is equal to Kp. This is the rate law expression for the EPO equation. Okay. Now, moving on to the next. Yes. Question number 26 to 30 are short answer type questions which carry 3 marks. This is the section C. Give the reasons for the following. First one, transition elements, they act as catalyst. Okay, we know that many of the transition elements are catalyst because of the tendency to show variable oxidation state or variable valencies. Okay, this is one of the point, and also they provide large surface area for the reaction. That is why they act as a catalyst for a reaction. Then the second one, it is difficult to obtain oxidation state which is greater than 2 for copper. Okay, that is mainly because after the removal of 2 electrons, it will result in the Cu2 plus state. Okay, the extra stability of the Cu2 plus state hinders removal of another electron. Okay, the stability of Cu2 plus N, or in other words, we can see that the higher amount of third ionization energy which is needed for the removal of an electron, a third electron. So, third ionization enthalpy for Cu2 plus ion or copper, which is greater. That is why it does not allow exceed this oxidation state beyond 2 plus. Okay. Now, moving on to the next. CrO, which is basic, but Cr2O3, it is amphoteric in nature. Okay. Here, we can see that CrO. Let's see what is the oxidation state of chromium in CrO. Here, oxidation state of chromium oxide, chromium in chromium oxide is +2. Okay. And what about here? It is +3 oxidation state in chromium Z. Okay. And if there is CrO3 molecule, what happens? The oxidation state will be +6 for chromium. Okay. So here we can understand that as the oxidation state increases, its acidic character also increases. So CrO3, which having +6 oxidation state, will be acidic in nature. And here CrO, which having +2 oxidation state, that is a basic in nature. Here we can see Cr2O3, in which chromium is in +3, which is in between those two. That is why CrO3 can show both acidic as well as basic nature. Okay. Now, moving on to the next. Yes. Arrange the following in increasing order of property specified. Let's check the first one. Aniline, ethanamine, 2-ethyl ethanamine. Okay. We have to arrange this in increasing order of solubility in water. Okay, let's see. Let's draw the structures first. This is aniline. Okay, the second one, ethanamine. CH3, CH2, NH2, which is ethanamine. And 2-ethyl ethanamine, CH3, CH2, CH3, NH2. Okay, 2-ethyl ethanamine. So, we have 3 of them are here. Here, in order to form or in order to soluble in water, it should form what? Yes, it should form bonds with the water. Okay, here we can see that CH3, CH2, NH2. It does not have any bulky groups here. So, it is easy for this species to form what? Bonds with water. So, it will be more soluble. Okay, here we can see that what happens here? Yes, there is a bulkier ethyl. R groups are in this carbon. So, the possibility of forming hydrogen bonds or forming bonds with the water will be less. So, the attractive interactions are less due to the bulky groups, bulky R groups. So, that is why it is less soluble. And here we can see that a hydrophobic ring is present. Okay. So, hydrophobic phenyl ring is present here. That is why it is insoluble. So, based on the solubility, we can arrange in the increasing order. How? First one will be aniline and then 2-ethyl ethanamine and finally ethanamine. That is the order. Yes, that is 1 and then 3, finally 2. This is the order, increasing order of solubility of these species. Then, moving on to the next question. Yes. Ethanoic acid, ethanamine, ethanol. That is the boiling point. Based on the boiling point, we have to arrange these in increasing order. Okay, let's see. Ethanoic acid. CH3, CH2, OH. This is ethanoic acid here. And then, next one is ethanamine. CH3, CH2, NH2 is here. And the third one, ethanol. CH3, CH2OH. Okay, ethanol. Here, the boiling point that depends upon the hydrogen bonding between the molecules. Okay, so the stronger is the hydrogen bonding, what happens? Greater will be the boiling point. So, here we know that oxygen, which is more electronegative than nitrogen, right? So, the hydrogen bonding formed between oxygen will be more. So, here, then we have two species here, which will be have more boiling point, high boiling point. This one, because it has two oxygen atoms. Okay, it will form hydrogen bonding between themselves. So, this one having more boiling point. And the second goes to ethanol, and this amine have less boiling point. Okay, so if we write, the second one have less boiling point, and then comes the third one. Finally, ethanoic acid has a more value. Okay, now moving on to the last one. Yes, methenamine, N-dimethyl methenamine and N-methyl methenamine. Okay, basic strength in aqueous phase. Okay, let's write the methenamine, that is CH3NH2, and the second one N-dimethyl methenamine. Okay, let's write the formula for that. CH3. Okay, there's a lone pair of electrons in the nitrogen atom, and the last one, yes, N-methyl methenamine, that is CH3NHCH3. Okay, these are the formulas of these given amines. Okay, we have to find the basic strength. We have to compare the basic strength of these three amines in aqueous phase. We know that. What is meant by basic strength? Yes, as the number of electron pairs increases in the nitrogen atom, or the electric nature or the negative charge increases on the nitrogen atom, its basic strength also increases. Here, we know that. What are the peculiarities of these CH3 groups or the alkyl groups? Yes, they are electron rich. They are electron donating groups. Okay, so as the number of electron donating groups, electron rich groups increases, the basic strength also increases. So, from this, we can see that this one, that is the methenamine, having less strength, basic character. So, the first one will be, yes, CH3NH2. Okay, now we have two of them. Okay, one is tertiary and one is secondary. Okay, so based on the above fact that we already discussed, we know that the tertiary one, which is having 3 CH3 group, that will have more basic character. But in contradictory, what we can say, secondary has more basic strength, because there is 3 CH3 groups, and these 3 CH3 groups are bulkier groups. Okay, that directly hinder this lone pair of electrons from donating to any other group. Okay, that is due to the presence of 3 CH3 groups, the basic strength decreases in the case of tertiary. Okay, so tertiary having the second one, CH3 and CH3. This will be the second one. Then, which having more basic strength? Yes, that is the secondary atom. Okay, secondary species. Secondary, I mean, that is CH3, NHCH3. It will possess more basic strength. Okay, this is the order for here. Okay, now we are moving on to the next question. Yes, give a chemical test to distinguish between N-methylethanamine and N-dimethylethanamine. Okay, we already see the structure of these two amines in the previous question. Okay, from there we understood that what? Yes, one is secondary and the second one, yes, that is tertiary. Okay, so we have to suggest a test to distinguish between primary, secondary and tertiary amines. What was the test? Okay, we know that is Heinsberg test. So, we use the Heinsberg reagent here, that is benzene sulfonal chloride. Okay, so when we use the Hinsberg reagent here, when it is treated with the Hinsberg reagent, what happens? The secondary will react with it and that will result in a product. So in the case, we'll get N-ethyl N-methyl sulfonamide. But in the case of this, it does not react with Hinsberg reagent. Okay, so it does not give any test or reaction with the Hinsberg reagent. So from that, we can distinguish between the secondary and the tertiary amines. Okay, yes. The second question. Write the reaction for catalytic reduction of nitrobenzene followed by reaction of product so formed with the bromine water. Okay, so we have to write the reaction of catalytic reduction of nitrobenzene. Then that product that reacts with the bromine water. Then we have to write the final product of these reactions. Let's see. First one, nitrobenzene. Let's write the nitrobenzene. Yes, this is nitrobenzene, NO2. Okay. Now, we have to undergo it is catalytic reduction. Hydrogen by nickel. Reduction occurs. What happens here? Yes. NO2 group is changes into NH2. Yes, here aniline is formed, aromatic amine. Then, we have to react this with bromine and water. So, what will be the final product? Yes, NH2 is ortho-para-directing. So, here, bromination occur in two ortho positions and para position. So, that will result in the product that is 2,4,6 tribromo aniline. Okay. We can see the product here. It is 2,4,6 tribromo aniline. Okay. Now, moving on to the third question. Yes. Out of butan 1-ol and butan 1-amine, which will be more soluble in water and why? We know that. We already studied that solubility is connected to strength of this compound to form hydrogen bond with water. Okay, here we know that in butan 1-ol, which is a alcohol, right? So, in alcohol, there is OH bond is present. Then, the second one, butan 1-amine. We know that in butan 1-amine, there is NH bond is present. Okay, which one is more electronegative? We know that hydrogen bond is meant by what? Yes, it is the attractive interaction between an electronegative atom with the hydrogen. So here, which one is more electronegative? Yes, we know that oxygen is more electronegative than nitrogen. So, OH bond will be more polar in comparison with the NH. So, the hydrogen bond that is formed between oxygen and hydrogen molecules in the water will be more stronger in comparison with the hydrogen bond that is formed by nitrogen and hydrogen in the water. Okay, so that is why butan 1-ol is more soluble in water. It is mainly because of the polarity, electronegativity and thereby strength of the hydrogen bond. Okay, yes. Moving on to the next question. Yes. 3 amino acids are given below. Okay, we have 3 amino acids are given. Alanine, aspartic acid and here last one, lysine. Okay, the question is, make 2 tripeptides using this amino acids and mark the peptide linkage in both cases. Okay, we have to form a tripeptide using these 3 amino acids. Okay, let's see. Let's draw the structures of each one. First, alanine. Let me draw the structure like this. That is NH2, CH, CH3, COOH. This is the structure of what? Yes, alanine. And let me number this as A, B, C. Okay? Okay. I draw the first A here And second, I take aspartic acid. Okay, let me draw the structure of aspartic acid like this. That is, yes, CH2COOH, and this side NH2. Okay, NH2 COOH, lysine, that is NH2CH, CH2 4 times NH2COH. This is the formula of lysine. Okay, now we have to form a tripeptide by joining what? These 3 amino acids. Okay, we know that how a peptide linkage or peptide bond is formed. Yes, OH from the first amino acid, okay, which is with the hydrogen from the amino group of the second amino acid released as minus H2O, which is eliminated as minus H2O, and forms a CONH linkage. Same as here, yes, the OH from the COH group of the second amino acid along with the hydrogen from the amino group of the third amino acid, that is released as minus H2O, which is eliminated as H2O and forms a CONH linkage. That is the second peptide bond or peptide linkage. Okay, so this is the first tripeptide. Now we can form the second tripeptide by BAC form. Okay, we can just switch the second and third one. Okay, let's see how it is done. Okay, let's write aspartic acid first. That is NH2 CH CH2COOH COH. This is aspartic acid and we can write alanine in the second. NH2 CH CH3 COH. Okay, here OH group along with the hydrogen released as H2O and forms a CONH linkage here, and also in here OH group and a hydrogen which is eliminated as H2O and a CONH linkage is formed here. So these are the 2 tripeptides formed here. Okay, now moving on to the next question, we have to answer the second question here. Yes, represent alanine in the Zwitter ionic form. So for that, we have to write the formula of the alanine. Okay, you already know that NH2 CH CH3 COH. This is the formula of alanine. Okay, here we know that COH is a acidic group. In aqueous solution, it will donate H plus ion. Okay, and what is the peculiarity of NH2 group? Yes, it is basic in nature. That means it can accept H plus by using the lone pair of electron. So, in aqueous solution, how the alanine occur or exist? Yes, it will lose the H plus ion and form CO minus. And these H plus ions are added to the NH2 group as NH3 by using the lone pair of electrons in the nitrogen. So, alanine exists as a Zwitter ionic form. That means a negative and positive charge which is in the same molecule. Okay. Now, moving on to the next question. Yes. Illustrate the following reaction giving suitable example in each case. Okay. We have 3 reactions here which is related to amines, right? Gabriel-Thalamide synthesis, carbylamine reaction, and Hofmann-bromamide degradation reaction. Okay, let's see each one. First one, Gabriel-Thalamide synthesis. In Gabriel-Thalamide synthesis, a thalamide which is react with what? Yes, a haloalkane and results in the formation of corresponding what? Amine. So this method which is used for the synthesis of primary amines. Let's see what happens here. Let's take first one is we have a phthalimide here. Then it is reacts with the alcoholic KOH. Okay, elimination of H2O molecule occur and here forms the hydrogen which is replaced with the potassium. Okay, then when it is reacts with the what? Yes, haloalkane. Here ethyl iodide is here. Then what happens? This iodine that goes with the potassium and potassium iodide is eliminated from here and the CH3CH2 group. That is, the K is replaced by CH3CH2 group. Then goes hydrolysis and after that we'll get phthalic acid plus our desired product which is a primary amine, that is ethylamine. In this case we get ethylamine because we take what? Yes, we took ethyl iodide. That's why we got ethylamine, corresponding primary amine. Okay. Now moving on to the next. Yes, the next reaction is carbylamine reaction. In carbylamine reaction, a primary amine which reacts with what? Yes, chloroform in aqueous or alcoholic KOH solution. That will result in the formation of an isocyanide. Okay, which is also known as carbylamine, which is a foul-smelling chemical along with the KCl and hydrogen. Okay, this is the reaction. So, since we take ethanamine, we got ethyl isocyanide. Okay, moving on to the next. Yes, Hofmann-bromamide degradation reaction. Okay, so in this reaction, an amide which reacts with the brominant NaOH and results in the formation of amine which having one carbon atom less than the parent amide. Okay, so this is the Hofmann-bromamide degradation reaction. So we got byproducts as sodium carbonate, NaBr and H2O. Okay, so this whole reaction can be explained from this heading or the name of the reaction. Hofmann-bromamide, yes. Amide is reacts with the bromine and degradation reaction. That means one carbon atom. The product will contain one carbon atom less than the parent one. Okay, we can take an example here. Here, there is an aromatic amide which reacts with the bromine and KOH that will result in formation of aniline, right? Aromatic amine is formed K2CO3 plus KBr plus 2H2. Okay, these are the byproducts. Okay, now moving on to the next. Yes. Okay, now we are moving into towards the session D. Question number 31 to 33 are long answer type questions which carrying 5 marks each. Okay, let's answer the 31st question. The first one is, write the reaction for crossed aldol condensation of acetone and ethanol. And the second question, how will you carry out the following conversions? Okay, we have 3 conversions here. Benzyl alcohol to phenylethanoic acid, propanone to propene, and benzene to metanitroacidophenone. Okay, now let's answer the first question. Yes, cross aldol condensation of acetone and ethanol. Okay, here we are doing cross aldol condensation. In cross aldol condensation, 2 different aldehydes or different ketones, they undergo condensation reaction and that will result in the formation of what? Yes, beta hydroxy aldehyde, which is also known as aldol, or beta hydroxy ketone, which is known as what? Yes, ketone. Okay, formed. And after, when we apply heat, H2O molecule is released and final products are formed. Okay, here we take what? Acetone and plus ethanol. In the presence of dilute NaOH, what happens? Yes, we get beta hydroxy aldehyde, which is known as aldol, and beta hydroxy ketone, which is known as ketone. Then if we apply heat, H2O molecule is eliminated from that and 2 final products are result. Okay, this is cross-aldol condensation reaction. Now, we are moving on to the next question. Yes, benzyl alcohol to phenylethanoic acid. How will you convert benzyl alcohol into phenylethanoic acid? Okay, we have benzyl alcohol here. When it is treated with thionyl chloride, what happens? CH2OH, OH is replaced by Cl group. And when it is treated with the KCl, what happens? Yes. The Cl is replaced by Cn and which undergo what? Yes, hydrolysis, acidic hydrolysis that will result in the formation of ethyl phenyl ethanoic acid. Okay, that's how a benzyl alcohol is converted into phenyl ethanoic acid. Now, moving on to the next one. Yes. How will you convert propanone to propene? Okay, here we have propanone is here, which undergo reduction. Then, the forms what? Yes, CH3, CHOH, CH3. An alcohol is formed. Then, after adding H2, treating with the H2SO4, what happens there? Yes, dehydration happens. There occurs dehydration and results in the formation of an alkene. Okay, that is propane is formed there. Okay, first they undergo reduction, alcohol is formed. Then after treating with H2SO4, dehydration occurs. That means H2O molecule is released or removed from that molecule. And finally, propane is formed. Then, the next one, benzene to meta-nitroacetophenone. Okay, so when we take benzene and it undergo what? Yes, it undergo Friedel-Crafts acylation reaction and that will result in, yes, this forms UNCH3s attached to the carbon to the benzene ring and then undergo nitration. Okay, nitration reaction occurs and we know that COCH3 group is meta-directing group. That is why NO2 is attached to the meta position. Okay. Now, 32nd question. State Kohl-Roche's law. Okay. What is Kohl-Roche's law? Okay, we know the definition, right? Yes. At infinite dilution, each ion contribute to the molar conductivity of that electrolyte. That is known as Kohl-Roche's law. And this law is used to find limiting molar conductivity of weak electrolyte. Okay. Now, moving on to the next. What are fuel cells? Write two advantages of fuel cell. First of all, we have to know what are fuel cells. Okay, fuel cells are electrical cells that are designated to convert the energy of combustion of fuels such as carbon monoxide, hydrogen directly into electrical energy. Okay, for that purpose, we use fuel cell. What is the most common example? Yes, that is the H2O2 fuel cell. Okay, you have to study the diagram of H2O2 fuel cell. Okay, now write two advantages of fuel cell. Okay, the first advantage is, yes, that have lower operational cost. Yes, lower operational cost. And the second advantage is, yes, they are highly efficient. Okay, in comparison with the other cells, they are highly efficient. Okay. Now, moving on to the next question. Yes, 33rd question, our last question. Define molar conductivity. Okay, what is molar conductivity? Yes, that is the conductivity of a 1 mole of a electrolyte. That is known as molar conductivity. Moving on to the next question. Identify the nature of electrolyte on the basis of above plot. Justify your answer. Okay, here we have a graph of an electrolyte. Okay, in the x-axis, there is C, concentration, and the y-axis, we have molar conductivity. Okay, from this graph, we can understand that as concentration decreases or on dilution, the molar conductivity increases. Okay, we already studied about the different graphs of weak electrolyte as well as strong electrolyte. Okay, from what we studied, we can understand that this is the graph of a strong electrolyte. Okay, then what about the weak electrolyte? Yes, if we take a weak electrolyte, this will be its graph. Okay, here we can see a straight line here, then there is a gradual increase and then straight graph. Okay, now the C question. Determine the value of limiting molar conductivity of electrolyte. So, what is limiting molar conductivity? Yes, here we can see that on dilution or when the concentration approaches 0, it should have a molar conductivity value. Okay, the conductivity, the molar conductivity at infinite dilution is known as limiting molar conductivity. Okay, here we have a strong graph of a strong electrolyte, here from which we can calculate the limiting molar conductivity just by extrapolating the graph. Okay, extrapolating the line in this graph. Okay, when it is touches the y-axis, that point will be the limiting molar conductivity of that particular electrolyte. Okay, in the case of a weak electrolyte, we use Kohlrausch's law to find limiting molar conductivity. Okay, now show how to calculate the value of limiting molar conductivity of the electrolyte using the above graph. We already discussed, we can just extrapolate this line into y-axis, and the point that touches the y-axis will be the concentration, will be the molar conductivity at zero dilution. Okay, molar conductivity as the zero concentration. That means it is the limiting molar conductivity. So here we get 150. Okay, so I hope the whole concept is clear for you. Okay, study well, happy learning.